What's up, guys? Today we'll be doing the AP Physics 2026 FRQ. We have ChatGPT and Gemini on standby just in case things get dangerous. We'll be doing version J of this FRQ. This is the first time I'm doing it, so I mean, I don't know. Yeah. Okay, let's see. Water exits the nozzle of a fountain at an angle of theta 0 above the horizontal. Wait, where's my shit? Oh. Okay. At time equals 0, a droplet of water exits the nozzle and follows the path. A droplet of water is crazy work. It follows the path shown in figure 1. Figure 1. The droplet reaches a maximum height of h1 above the nozzle, which is right here. At t equals tf, the droplet returns to the same height at which the droplet exited the nozzle. Ooh. On the axis, in figure 2, sketch the graphs of the horizontal and vertical components of the velocity of droplet as a function of t. T equals 0 to tf. Okay, so at horizontal, okay, this is actually pretty easy. So the only forces acting on this nozzle, the moment it exits the nozzle at least, is gravity. So it's getting pushed at an initial velocity due to the force of the nozzle at some VO, and it will continue into a constant x component, constantly go that way, while gravity tries to drag down the velocity to negative. So that means horizontal, if we assume velocity to the right is positive, we'll just do this. And for vertical, since it's velocity, let me think about it. Okay, so since there's an acceleration, and it's constant acceleration, F equals ma, or just a, equals g, right? And so we took the integral, we get velocity equals gt, and this is a linear line, plus c, can't forget. And we know that plus c for the vertical, since it's initially going upwards, c is a positive number and g is a negative number. So that means that we start at where c was right here, and we go down to velocity 0, which is at this point where it stops going up but doesn't go down. And at t final, it will be at negative c again. It will be at the opposite, yeah. It will be at negative c, because symmetry. Okay, that was the easy first question. Let's do part B. Oh shoot, is there more? Okay. Okay. Hello. There you go. Derive an expression for the speed of water exiting the nozzle. Express the final in terms of theta, 0, h1, and physical constants as appropriate. Begin your derivation by writing a fundamental principle or an equation from the reference information. You see, they try to trick you into believing that this question was about fluids and Bernoulli's principle. But the moment that water exited out the nozzle into the open air, that's how you know it started acting like an object in UAM. So, if you want theta 0 and H1, and we want the speed, okay. So, let's get it. Okay. So, let me see what we have. Only theta 0 and H1. I'm not to think about that. Let's just think about one. Okay. So that means I think so we're probably gonna have to use this one if I'm correct. VO. Wait, it's at the speed of the nozzle exit, yeah. Equals oops, plus 1/2 GT squared. Now T and X cannot be in this equation. Sucks to suck. Okay. So now that I think about it, let's think even further. So let's think about what the velocity is equal. So VOY, which is let me see, like speed. Okay, so it's asking for the vector, not the component, right? Let me see. Read it again. Yeah, this asks for the component. So so more or less not changing X, more like just changing whatever, but there's gonna be a oh shoot. Yeah, it'd be change. Oh my god. So instead of changing X, I'd put H1. VO T plus 1/2 GT squared. Or AT squared, but it'd actually be minus 1/2 GT squared. Or should it be plus? I have no clue. If you count the pause, we'll just keep positive. So now we just gotta find theta. So VO in this case would be actually VOY, because you're using the height. And basically, since it's VOY, if we do a triangle, this part is VO, and if we assume this is theta, right? Okay, theta is adjacent to the horizontal, so then it's sine theta. You plug that into VOY, you get VO equals H1 minus 1/2 GT squared. Wait, we might have to get rid of that T squared though, I don't know how. Over, wait, I got this. Or maybe I don't. So we know that VOX equals does it say frick? Okay. VOX equals change in X over T. It doesn't even change. VOX. I'm really struggling how I'm gonna change this into change in X. Oh wait. Oh shoot, I'm stupid as hell. I've been doing this for no reason. Okay. Wait. Or am I? Oh yeah. I'm actually dumb as hell. I should have been using this one. Oopsie daisies. That's what happens when you don't do physics for a long time. So, with this, you can assume BF is 0 because it's at the top, so you can get rid of that. And then you have B squared, and then you assume the G gets negative, so then there's no negative square root, and there's your answer. Wow. Could have done it instantly if I realized that sooner. Whatever. Anyways, next problem. The nozzle has a circular intersection, derive an expression for the volume flow rate. Now this is where I have to say I have no clue because I don't remember my equations. I swear it's like some radius times something, radius 1 equals, I don't even know. Derive an expression for the volume flow rate. I swear volume flow rate is straight up velocity radius equals velocity radius. God. Yeah, this is the one where I'm gonna have to check the equation sheet because I forgot. Oh, there is no equation sheet. RIP. Frick. Volume flow rate, like I know what that means. What is the flow rate equation? I forgot. Bernoulli, help me. I'm thinking of it. I feel like I want to use this one, but I don't really want to. It's like cross section times velocity. But then I don't know the second cross section. So then what I have to use Bernoulli's equation. But I need to know what flow rate is. I have no clue what the flow rate is. I know it's volume. I mean velocity at some. The variable is probably velocity. But I just don't know. Sheesh. Probably have to use this equation too, by the way. So, given that this is the initial, maybe it's now the new final of the volumetric flow rate, and that some pi r squared times velocity initial equals pi r squared equals pi r. Let me read it again. Exiting the volumetric flow rate. Shit. Like I know. I know it's constant. That's all I know. Oh my god, I'm gonna search this up. Volumetric flow rate. Oh yeah, I'll just search it. AP Physics equation sheet. Oh my god. Give me a better freaking image. Okay. Where is flow rate? That is not flow rate. Oh, there is this one. But I don't know what velocity to the first and second freaking thing is. Let me read it again. Oh no. I don't know what the second A is. I don't want to know either. See if there's something I can find here. Yeah, nah. Alright, I searched up what is the volumetric flow rate equation, unfortunately. I don't know anything. A V1 equals A V2. I don't know what the A is for the second one. Like, okay, let me reread the question. It has a circular cross section of RO. So then, like, what is the initial? Okay, so the like like there's really nothing. There's no A1 AV. There's nothing I can write about this unless you want me to cancel it, and then I just write that this is the equation again. This is where you chat GPT it. Guys, this is where you have to chat GPT it. I'll just do part B for now. The fountain nozzle is replaced with a new nozzle of a smaller radius than RO. The water exits the new nozzle at the same angle theta above the horizontal. The flow rate of the water is equal to the flow rate of the water exiting the original water exiting the new nozzle to the maximum height of H2 above. Assuming what I just thought, that VF, it's still gonna be the volumetric flow rate is probably this, but really isn't. Given that, gonna have to assume H1 equals H2. So we're gonna circle this one. The reasoning, smaller radius, same speed of water coming out. And we look at the equation, the only thing that affects height is the height, or the only thing, yeah, alright, if we, in comparison to velocity and height, the only thing that affects the height is the velocity, and if we're given that the velocity is the same, then therefore the same height. Now, do I truly believe that? I don't really know if I truly believe that. So that is why we are going to ask ChatGPT how to answer the question. Answer all. Okay. I was supposed to solve for H1. When was I supposed to solve for H1? AII. Are you sure? Man, I gotta be dumb as hell. By the way, I don't know. Yeah, it's over. It's over. Wait, no. Why is this guy solving for H1 elite as it does not ask for the peak height? It literally asks for the speed. Are we dumb? Yeah, I'm dumb as rocks, bro. Holy. I'm dumb as rocks. Anyways, so yeah, pi r squared. Volumetric flow rate was pi r squared square root 2gh1. And the same volumetric flow rate. So, given that it's the same volumetric flow rate, but a smaller r, solve for h1, we get v pi r squared. Alright, basically, h1 is proportional to 1 over r. And that's basically saying the smaller the r, or at least h, just put h, yeah. So the smaller the r gets, the bigger h gets, and the bigger that r gets, the smaller h is. So given that we now know what this means, the new answer should be this, which ChatGPT agrees with me with that one, I think. What? Wait, am I dumb? Yeah, okay, so you do that. What the fuck? Yeah, ChatGPT had that completely wrong. What the hell? I'm gonna have to take a massive poo later. So hurry up, Gemini, and you take a poop. Yes. Oh wait, did I forget the sign? Embarrassing. Yeah, I did forget the sign. Oh shoot. Yep. Okay, so we're using Gemini, not ChatGPT, I guess. Okay. Ugh. I technically had that. I just had a brain fart. It's been a long day. But either way, yeah. I didn't believe my answer was right, but when I did correct the answer, I got it right. So yeah, there you go. H2 is greater, and let's see the justification. Yeah, since everything else since everything else is the same, the angle, the velocity, the constant of force, gravity is the same, volumetric flow rate is the same, radius different. And the angle is the same. Then we get to the idea that h is inversely proportional to r, so therefore, if r is smaller, h will get bigger. There you go. And I take a shit now. Change of scenery. Oh, low key easy. I just have to warm up a little bit. This time, I'll go faster. Hold on. Let me erase all this. I just decide. Bro. You're not real. I gotta go. Alright. Let's go with, we're skipping the lab, by the way. I'm not doing a lab. Okay. Alright. Two small disks, R and S. Okay. At time 0, it's located at x equals 0, is moving with speed VO in the plus x direction. Wait, what? R. Okay, R is moving to the right. S, so 3MO is at rest. It's gonna be a momentum. At T equals T1, they collide. Immediately after the collision, R moves with speed 1 VO in negative x direction. The momentum diagram represent. Man, I didn't even freaking screenshot any problems. Wow. Okay. The question is, draw arrows on figure 3. Okay, so I should probably take a picture of that. Okay. It says, draw arrows on figure 3 to represent the momentum of the vector. Draw arrows on figure to direct the momentum vectors of razor after the collision. Each arrow must start on the point on each dot. And the momentum of if either disk is 0, write P equals next to the dot. Draw a length of each magnitude. Okay, so before we even do anything, we have to solve. Okay. So this R momentum equals VOMO, or 1/2 VOMO. This is negative, okay. And then plus momentum of S final, which is equal to the momentum initially. Since this is at 0, we just don't write it, which was, and this is just MOVO on the before, so this is after before. So initially VMOVO, and then it hits and it goes the opposite way. So solving for the momentum of PSF, we get that the momentum PSF equals 3/2 P. Okay, I'll just say PR initial, cause yeah, 3/2 of PR initial, right? But wait, you know what? I'll just write it as VOMO. So we take the ratio of this to find vectors. Say, oh, if this is 1/2, if disk R is 1/2, we have to draw. I would draw like, I'll draw like right here. And RF equals negative 1/2 VOMO. And then that would just mean PSF is equal to negative 3 times PRF. Right? I think so. Yeah. Well, I mean, I would have figured that out easily without having to do that ratio, but whatever. So if this is too long, I'm gonna have to make this 1, 2, the opposite direction. 1, 2, 3, 4, 5, 6. Wait. 1, 2, 3, 4, 5, 6. There you go. Yeah. Now, what am I gonna do with all this random yap? I don't know. Okay. So this is what it should look like. The easy stuff. Okay. Yeah. Wait, that right? Draw the length for the magnitude consistent with the scale of figure 2. Oops. So, my God. This is okay. If we're going consistent, then we did not have to do that ratio. I know, my dumbass shit. Anyways, so if 1 MO is 4, 1, 2, 3, 4, that means this is a quarter. So that means I was safe to say that R was too long then, because it's only the opposite and half of it. And then now this one would be 3/3 of it. Wait, did I technically get that right anyways? So I take it by half, and then 1, 2, 3, 4. I think I did it right anyways. Whatever, yeah. I mean, the scale, like, I lead guessed 2, still had it right. Okay. Starting with the conversion layer, we want to derive an expression for the kinetic energy of disk S after the collision. Make me crush out. Okay. So, like I showed earlier with my work, 3/2 MOVO was the momentum of PS final. Alright. Oh, shivering my timbers right now. Or you can say that the V, or I don't know where I wrote V. Oh yeah, it is VO. That VO, or frick, I don't even know anymore. I don't know anything. Whatever. Okay, so whatever I did earlier, yeah, and then sigma of Ki equals Kf, and then you get 1/2 MOVO squared. Wait a minute. Did I forget something? I am a dumbass, aren't I? Guess what? Waits for it. Yeah, there you go. Reason being, I forgot this 3 had 3 mass. So you divide it by 3. And yeah. Once you divide by 3, it's game over. I mean, actually no, the velocity. Oh no, never mind, I'm not wrong there. I'm the dumb one. Momentum is still 6 long. It's just that the velocity is 1/2. Because MVS so equals 3/2 MOVRO. And so basically you divide, cancel, VS equals 1/2 MOVO for R. Alright, so with that in mind, it says derive measurement for the kinetic energy of S. Did I really need to write this? Probably not. I don't think I did. So Ki equals Kf. Ki we know is 1/2 MO. Wait, no, it should, yeah, 1/2 MO VO. And on the other side, it would be kinetic energy of R, wait, R or, yeah, kinetic energy of R, S, plus kinetic energy of R. But we know that the kinetic energy of R is, after it at least, is MO times, oh my god. Okay, this is 1/2 VO. So, yeah, we just plug in 1/2 VO in there, square it, I forgot the square here, and then that's 1/4, 1/8 squared, so then it's 1/2 minus 1/8, that's 3/8, I think, MO VO squared equals KS, final. Is that right? Yep, that should be around right. 1/8 minus 1/2 should be 3/8. Yeah, there you go. The graph shown in figure 4. Oh, I forgot another screenshot. Oh my god. Okay. The graph in figure represents the position x as a function of time. Hello. At t equals 0 and t equals t1 until for each to find this in the center mass of the disk. Okay, so you see, so T1 was before it got hit, right? Okay. On the graph, if we will draw 3 lines that represents the positions of the from T1 to 2T1, distinctly labeled each line. Alright, so disk S, this is distance, right? Okay, position, distance, whatever. Okay, so for disk S, first, okay, I think the center of mass doesn't change. I think it's still going straight like that. If I believe so, that the center of mass still has the same velocity because it's a conserved system and there's no force acted upon it, outside source. Alright, force. This R's positioning starts to go downwards. Now, I don't know exactly how down, but we can figure it out later. Alright, you know what we could figure out? Because since it has to be conserved, what's the slope of this line? Slope of this line is so 2t, or actually no, I'm dumb as hell. What the hell am I doing? Okay, t1 over 2 units of y, and this originally is 1, 2, 3, 4. Wait, 1, 2, 3, 4. So the second one is 4 over t1. I don't even know what I'm doing actually. Slope of this is 0, so I actually don't know what I'm doing. Something has to be conserved here. That's all I know. Something has to be conserved. And you could probably draw this line, given that knowledge. So maybe that I didn't have to draw 2T1, or maybe I had to draw 4T1, and they all have to add up to 4 T1 either way or something like that. I have no clue. Okay, so in terms of perspective, like I wrote earlier, Vs equals 1/2 MOVOR. So if we took the integral of this, we would get position XS equals 1/2 MO and VOR. It's in respect to time, so it's distance over time. Wait, am I doing this right? Or am I dumb as hell? I might be dumb as hell. Okay, I can't do it like that, my bad. Oh, this is bad. Oh wait, the slope, oh my freaking god, the slope of the line is the speed. So, if initially the slope of the line was 4/T1 for MO, then the slope of this one has to be half, so I feel like the slope would just be half, yeah? So now, half of 4 is 2, so I would say that this is the line. Oh, shoot. I can't draw lines anymore. Okay. And we know now that VS, let me see, actually, I want to have VO. So, VS, I have to get rid of MO. So, yeah, it's the same as well. So, minus 2, okay. So, two twos, broski. Wagwan, my brother. Should be here to here, and here to... Can't draw for anything, bro. What the hell? Okay. So this is S, R, and C, com. Yeah, there you go. Is that all? Let's see. Okay. Okay, during the collision, the magnitudes of changes in momentum R and S are represented by that. Indicate whether change in PR is greater or less than change in PS by writing the following. By referencing a fundamental principle. Shit. Okay, let's think about it. Change in PR is equal to the change in velocity times the mass. So MO, and the change in mass was VO to VO, so it's 1/2 VO, which is just 1/2 of itself. So 1/2. So it's the change is just 1/2 of itself. And then for PS, it went from 0 to the momentum was 3/2, which was this, which is equal to 3/2 PR, which is obviously greater than PR 1/2. So for the explanation, well, you'd be circling this one as 2 physical fundamental principle, we can say by the principle of conservation of momentum, PR must the impulse of PS must be greater than PR's, because wait, hold on. No, it's PR. Wait, hold on. I'm actually trolling. PR went from MOVO minus 1/2, so they're actually the same. Yeah, I was about to say conservation and momentum, they should have been the same. Okay, and since the absolute value signs, they're 3/2, yeah. Okay, so they're the same because due to the conservation of momentum, the change in momentum of both systems, since they're in the same system, should be equal to each other, or something like that. I don't know, clue. They should be equal to each other because they're both in the same system, and because they collided with each other, they will by conservation of momentum, they will have the same change in momentum. That's because when they bump into each other, they should distribute the momentum equally. And that's why. Yeah, there you go. And that's going into Gemini. Why is this actually 3 pages? So, I'm lacking in explanation, but I just know the answer, bro. Let's see if I'm right. Let's see, so 6 units, 4 units. Did we do that? 1, 2, really? 2 long to the left, yep. 6 long, we did 6, okay. Yada yada, 3/8. Yup, there you go. Time graph position. Let's see. R should have a negative 1/2. Half as deep as the original slope. That's what I'm saying, bro. Oh yes, we are locked in, bro. We are locked the frickin'. Okay, so yes, we did this. We did not invoke Newton's third law. Should have. Honestly, that is probably a better explanation of impulse, using Newton's third law. Go to a magnet in opposite direction. Yeah. I don't care. Yes, so again, I'm right as always. That's another easy one. So, how do I delete all this, bro? Let me delete all this right now, bro. Delete. Okay, can I just do this and just delete? Delete. You're gone. Okay. Alright. That's another easy one knocked out. Let's see if this is the lab. Maybe I don't even want to do this, bro. Indicate which components to determine mu k using a linear graph. We will find a mu k. Oh, that is nasty, but yeah, good luck with that one, bro. find mu k. Let me think. How would you find mu k? Equals Fn equals the force of friction. Divide the two. And then you have to go into nitty gritty on what the force of friction is on this dumbass slope, unless it's asking for mu k or something else. Oh, the horizontal. Okay, it makes a lot more sense. So I assume they want you to drop it, calculate the speed at this point, and then see the distance at which it travels using the conservation of energy and work to find mu k, obviously. How are you gonna find? I just saw photo gate, right? So you're probably gonna use the photo gate to find the speed or whatever. I don't know what photo gates does, and that's exactly why I'm not doing the lab. I have no clue what that does. But that's what I assume you're supposed to do. Use conservation of energy, and using work, maybe. Yeah, not conservation energy. Or maybe conservation of energy for this part. We don't even need a photo gate. Just measure this part. And then, once you're here, you have the energy, so mgh equals 1/2 k, so you have the velocity here once you know the height, assuming no friction, of course, between this and this, the ramp. Okay, and then once it slides down here, you get the initial velocity, and all you have to do is have... Okay, so and then you set up a new system of a new equation that's saying the kinetic energy at the start equals the work because it stops at 0. So then you get, so work equals FD, so that's 1/2 m squared. You have to get the weight of the block, and then if you substitute everything, you'd get force equals or mu k rather equals, now I'm not writing all that out, but you get the idea. Once you find the height and set up the equation, 1/2 mv squared equals mgh, that is equal to square root 2gh, and you set that equal to fd, f equals mu k fn, which is mg. So basically, if you want to find mu k equals the distance the blocks travel. Alright, so it's equal to square root 2gh divided by m and the distance times the distance of where the block, whatever. Yeah, I think that's about it. Yeah, distance, velocity. Well, I mean, you're probably calculating the actual velocity of that one. And a different experiment. Wait, is this actually a lab? Okay, yeah, it is. Indicate what quantities the graph to get the linear line determine. So it probably wants slope. Like I said, 2gh. So you want to probably graph height to mass, maybe 2gh and distance. I mean, mg. And you do a little bit of this, a little bit of that. Yeah, you're gonna have to do height versus okay, so if we assume mass is also constant, by the way, so then the only thing that isn't constant is presumably, wait, need two varying things. So the thing that will vary for sure, oh wait, let me see what changes. It's the mass. It can't be the mass. Okay, I'll assume that the height of the ramp can be changed. Because the only thing that you could measure is height, mass, and distance. But mass is obviously not going to change. I mean, unless you want to, I guess. Or you can do 1 over m versus d, but like, so dumb. Okay. Yeah, probably that, I don't know. Reveal this kind of relation between mu k and the future graph, just say it's a slope. And a different, let me see what's all this saying. Use a different, the student release a block from rest on a rough ramp. The block is released distance d from the photo gate. The ramp is at an incline theta above the horizontal on figure 2. The block slides down the ramp, passes through the photo gate, which is positioned near the bottom of the ramp. The photo gate determines the speed v of the block as it passes through the photo gate. The unknown coefficient of friction between the block is mu k. So given d and m, so here's the thing. If you know d and v, you just need to find the mass. Search correctly answer that d is 2g sine theta. Yappity yap. Are you sure? Is that actually the equation? Think about that. You get 1/2 fd cosine theta. I feel like I've seen this equation before, but I feel like that's for pendulums. Or am I tripping? Because this d means this is the force. Okay, so the 2 comes from the 1/2. M, I assume, cancels out. 2g from the outside means there was mg. So the word is sine and cosine come from? How am I supposed to know? The relation between d and v. Alright, let me see. 1/2 equals mg. Oh wait, because of fn is on an incline slope. Okay, I get it now. Yeah, makes a lot more sense from that perspective. Yeah, we're not doing that. Okay, I spent like so much time yapping about nothing. Good job. How much time are you given for AP Physics FRQ? 100 minutes? Really? I mean, I did skip the freaking lab, but like, we have 40 minutes left. Too freaking easy. Okay. Toy X are free to rotate for negligible friction about a vertical through the center of each toy. The upper proportion of each toy has a radius RO as shown as a side view of figure 1. It has a length LO as string length LO is completely wrapped around. What's the string gotta do with anything? A string of length is wrapped around the upper portion of each toy. The rotational inertia, so I assume that it's wrapped around in this, is that, I don't know how this toy works, bro. The string, LO, so I assume you gotta like pull it up or something, I don't know. It's bad. So basically, same RO, same FO, different inertial masses. Toy X are initially at rest. The constant force on the string of the toy, which causes the toy to rotate. Oh, so you pull it from that way with the string. Okay. As soon as I figure that axle is vertical as the forces are vertical. These do not slip by when the string loses contact. The axle. The axle? No clue what that is. Okay. Indicate which one is faster. So, what equation can we relate this to? We can relate this to probably energy, right? So, it has 1/2 I omega squared, and it can equal to the work. So the work is F and LO, or no. With the work, yeah, the work would be RO, not LO, I think. Yeah. Does the string length even matter? I don't think it does. Because it's always being pulled LO from the axle, so I don't know. So if we're using work, and that work is all translated into kinetic energy, then it would be, well, we'd write torque and radius, right? Would it be torque and radius or distance? I think it might low-key be LO. I'm sorry, I lie. Okay, but regardless, since LO and RO are the same, regardless of what this D can be, the rotational work of torque, so whatever it will be when you write it down as as F times R, and perhaps R or L, I don't know, and it's equal to 1/2 omega I squared. Wait, I omega squared. And we solve for it. We get, well, let me see. And then we substitute in for I. X is probably some, I don't know. And we look at omega. So if we compare omegas, we'll see that F, R, or L are the same, so they all cancel out when you divide by omega 1 and 2. The only difference is 1 over I 2 over 1 over I 1. And when we turn it around, it'd be I1 over I2, or Y, it should say Y. And this is X equals omega Y over omega X. And we can see that they're inversely proportional, I think. Yeah, I and X, I 1 over I inversely proportional to omega. So basically, the omega the I that is the smallest, which is tau y, which is also the skinniest, should have the highest omega, or rotational speed. So therefore, you should probably circle this one. Qualitative reasoning behind the references. So Qualitative reasoning. Since everything is the same but except I, and I is inversely proportional to omega, it should say that the smallest omega of the two should result in the biggest omega. There you go. Part B, starting with work energy theorem. Our news will derive an expression for the angular momentum x. Oh, I think we already did that. Instant contact of LO. Yeah. Given the fact that there is an LO, I'm gonna assume it is LO. Is there R? Am I allowed to use R? Nope. So you can use LR. I mean, you can't use R. That's bad. LO times FR. Oh, we can use FO, but we can't use FR. Okay, bro. Divided by IX. Times 2 equals omega X. There's like literally nothing else you can cancel R with. Or am I tripping? Like you can use FO. Wait, I'm gonna have to think. Because this is rotational inertia given from a linear pool. So is there really even an R here? Let's search it up. We'll get the AP. Let's see if there is a rotational version of concept of work. Oh, change in theta. My fault, gang. Well, the change in theta times LO. Shit. Well, torque is obviously equal to FR, and then the work, it said work energy theorem, right? Work energy theorem. So we started from torque, change in theta equals work. So, does R change in theta ring a bell? Well, it's equal to velocity tangent times time. I have no clue. Can I just assume that the work is linear? Probably not. Or Newton's second law. Would that make more sense if I use Newton's second law in rotational form, obviously? So, Newton's second law in rotational form, I'm supposed to find the expression for angular, equals I alpha, right? I'm gonna have to look at the AP physics sheet. Torque equals this. Yeah. Okay. RF. I mean, like, how am I supposed to freaking do this? I guess R equals to something like. I know omega R equals velocity tangent. So then that would mean that velocity tangent equals R theta over change in time equals R omega. Cancel those out. What am I doing? So I'm essentially saying that because R is in the equation, I could say that R the radius is equal to, no, that's not gonna work. How would I even get LO into this? Oh, that's bad, bro. That is actually bad. I don't know how to cancel R. It says I can't use R. The only way I can find to get R out is if I use the linear form of work. But if I also went the Newton's second law approach, I don't know what it means by Newton's second law other than torque equals F, the summation of FR. But you still can't get rid of FR. I don't know how you'd get the length of the string from R, or yeah, basically R. And it's equal to I alpha. Alpha alpha equals omega. Wait, centripetal acceleration equals omega squared R. Let me think about this. Alpha equals equals A tangent. I think it's R times alpha equals A tangent. Right? Is that even part of the? Yeah. Okay. Yeah, I was right. And so, A tangent equals omega squared R over R. Cancel that out, and that's IX omega squared. Wait, no, because you can't have that. Oh my days. You legit cannot get rid of R. I'm telling you, you cannot get rid of R, bro. You straight up cannot get rid of R. Alright. Have I already done one? I might be. Because if it's alpha over R, I don't know. It's bad. Velocity equals R omega. Yeah, this is what you're supposed to start with. A system equals torque net, right? And this alpha equals AT over R. Wait, I think I got it. I might have done one after all. Let me see how much time I have. Did I spend 40 minutes of my life? I spent 13. Okay. Okay, so alpha equals FR over IX. And then alpha equals A tangent over R. Oh shoot, this is actually bad. This is not good. This is not good. Bro, but I know that omega squared R is equal to A tangent, right? Acceleration centripetal omega relationship. Yeah, I'm right. So then that would mean that A is equal to omega squared, right? But that still leaves the FOR in there, which I'm like, is it constant? Like, I don't know. Like, I seriously don't know. Wait. So the axle is this, in which it is spinning. So you're still, so yeah, there's an RO. Like, I seriously don't get how to get rid of that RO. Because alpha equals AT over R, meaning alpha, wait, that would just mean alpha is equal to omega squared. That doesn't sound right. But given our relationship, might as well be. We're talking about after though. So there is no force, right? Or am I wrong? Oh, I'm getting a brain fart. Because it says derive omega after the string has been pulled, right? The instant the string loses contact. So the force should equal 0, no? Or am I done as hell, bro? Alpha equal FR. You really cannot fix that. So how else are you gonna get rid of it? You're not getting rid of torque. Torque equals FR perpendicular. And you can't say FR suddenly just disappears. Unless R is equal to L somehow. And I just forgot, I just can't read. Oh my god. Well, anyways, justify your equation. Assuming that, you see it's inversely proportional. I just can't show how. I might probably stuck on this equation and just watch how I could still use R in my equation. Like, it's actually like, there is no way you can just get rid of that R. Or at least for the equations given that, and I know. Let's see it. Yup. So y is greater, because like I said, y was greater. Derivation. Wait. I might have been dumb as hell. Wait, no. That doesn't make sense. Okay. For the force, that actually makes sense. Because you're applying the force over the length of the string. Can you show how to derive equation using Newton's second law of rotation? Okay. And theta equals L over RO. Hold on. The length of the string over RO was theta. Oh no. Oh no. I might have been dumb as hell, bro. Okay, but like, think about it, like, ugh. Bruh. Bruh. Length over R. Because circumference equals 2 pi r. So that means pi or theta equals theta r equals a portion of the circumference. And so therefore L over R equals theta. I'm just a robot. So you can do it linearly. And then that just begs the question, what does it mean to use torque over using work as torque? Torque as work. What is torque as work? Let's search this up. Examples of torque work in physics. Oh, T theta. Turning a doorknob using a wrench. That makes sense. Because you apply the torque around the thing. Around. And theta equals length over r. So then. This is getting too out of hand. Perhaps if I studied the physics a little bit, I would have gotten a more confident score. I'd still say I would have gotten the answers. Just unconfident of my answers, though. Still would have gotten it, though. Just very unconfident of it.